This video is more examples of proving transformations. Again, we're going to predict the transformation occurring. We're going to verify it by proving it using slope, distance, midpoint, etc. Then we're going to write a mapping rule for the transformation if it's possible. So the first thing we do is predict, a prediction. So if we look at our figure from our pre-image to our image, so our pre-image is inside of here, then our image is outside. Now, as you can see, the sizes are different, and the only transformation that has different sizes is a dilation. So that's the only one that this could potentially be. So we're going to put dilation for our prediction. Now we need to know the properties for dilation. The properties for dilation is say that AB is parallel, I'm going to use a symbol for parallel, to A prime, B prime. That BC, line BC, is parallel to B prime, C prime. And AC is parallel to A prime, C prime. Again, these are different letters, so there's only 3 of them here, but now we have to do 4, because there's 4 different lines. And then we should also show that AA prime, B prime, and C prime all pass through the center of dilation. So what that means is that when we connect them, if we've proven this part and we can find where they all go through, we would be able to find our actual center of dilation, which generally it will be 0, 0, but we can always check that. So the first thing we need to do is our slopes, because it says parallel. So I'm going to highlight that, all these in yellow. Now parallel means we're going to have to do all different ones. Because these are not just AA prime, BB prime, CC prime, we actually will have a slope, 2 slopes for here, they should be the same. We'll have different slopes for these, but they should be the same to each other. Then we'll have another different slope, but they should be the same to each other. And then since we have 4 lines, we'll have 4 of them total. So if we do this, we do our slopes. So I'll actually put it down here, slopes. We want to do for parallel. This is because of parallel. So we want to find the slope of, since it's AB from our pre-image, so we really have the letters K, Q, P, and D. So I'll find the slope of KQ. We'll find the slope of K prime, Q prime. Then we'll do the slope of QP. So I'm going to fix that real quick. I just meant to put the M for the slope. M of QP. So then we'll do the M of Q prime, P prime as well. Then we'll do the slope of PD. And then M of P prime, D prime. From here. And then we'll finally do DK and then D prime, K prime. So then the slope of DK and then the slope of D prime, K prime. Yeah, I did not mean to put that equal sign. So finding the slopes, we do our rise over run. So KQ. K to Q is rising up but running 0. This is a vertical line. This is actually an undefined slope. So we'll put that this is undefined. And then for K prime, Q prime, it's also vertical, so it's also undefined. Remember, a vertical line is undefined, a horizontal is 0. So if these are the same, then these are parallel, which we have to prove. We have to prove 4 of them. So we've proven 1, we have to prove the other 3. QP. So we have to go up 1 and then write 1, 2, 3, 4, 5. So this is 1 over 5. Now Q prime, P prime, we have to go up, that's a half plus 1. So that's 1.5. 1.5 over 1, 2, 3, 4, 5, 6, 7.5. 7.5. So 1.5 divided by 7.5. You put in your calculator 1.5 divided by 7.5, you get 1/5. That's equal to 1/5. Therefore, these are also parallel, which is good because we needed 4 of them total. So these up here we have 3, but we need 4 in total. So we have 1, 2 already. And we'll do P to D. So we go down 1, 2, 3, 4, left 1, 2. So that's down 4, left 2. So that's -4 over -2, which is equal to a +2. So from P prime to D prime, we went down 1, 2, 3, 4, 5, 6, and then left, that's a half, 1.5, 2.5, plus another half is 3. So that's down 6 and left 3, which is equal to also a +2. So those are also parallel. These are at half marks. So I just went down because I didn't have to worry about the half right now. Just went down, and then I did a half. Then this is 1.5. That's 2.5. Then plus another half gave us the 3. We went down 6 and left 3. That's what gave us the 2. And then finally for dk and d prime k prime. So dk, we have to go up 1, 2, and then left 1, 2, 3. So up 2, left 3. So 2 over -3. That's just a -2/3. So d prime k prime, d prime, up 1, 2, 3. So that's up 3 over. We're at the middle. We're in the half. So that's a half. 1, 2, 3, 4.5. So that's a half right here. Then we have 1.5, 2.5, 3.5, 4.5. So over -4.5. So 3 divided by -4.5 is equal to a -2/3 as well. So it doesn't matter if the negative's on top or bottom here. This is a -2/3. This is -2/3. Therefore, these are also parallel. So we have, in fact, proven that all of the lines are parallel, so that this should be a dilation. And we can actually determine if it's a dilation, determine the scale factor. We know it's going to get bigger, so it's going to enlarge. And we also want to find the center of dilation. So to find the center of dilation, you connect the coordinates, A prime, B prime, C prime, or whatever the actual coordinates are. I'm going to use a ruler to actually connect these. So I have P prime and P. I'm just going to draw a line. So it looks like it's going through 0, 0, but it's going through a whole bunch of other ones. I want to find where all of the points go through. So I do D prime and D. And they are going through 0, 0. So far it looks like the center is going to be 0, 0. K to K prime is going to be just the x-axis, so that also goes through 0, 0. And then finally Q to Q prime. So Q and Q prime, connect them. Try to at least. We'll go through 0, 0. I was off a little bit when I did my ruler. So the center of dilation is actually at the origin. So that means that it does have an actual mapping rule. It will have an actual mapping rule. So let's determine that mapping rule. Since these are all parallel, we can actually take one coordinate and determine the mapping rule by doing our image over our pre-image. So if we want to do our scale factor, our K is equal to our image divided by a pre-image. So if I just take coordinates, if we focus on maybe P and P prime. So if we do image is P prime, that is at, so we're going to have X's and Y's. the x is at 1, 2, 3, 4.5, and the y is at 1, 2, 3. Now, for the pre-image, your x is at 3, and your y is at 2. Now, we just got to check 4.5 divided by 3 is equal to 1.5, and 3 divided by 2 is also equal to 1.5. So our scale factor is actually 1.5. So we can have k equals 1.5 or k equals 3 over 2. That means we have a scale factor. So we did do a dilation. This is dilation. And our mapping rule, since it did go through 0, 0, we can do x, y maps to. Our k value is 3 over 2 or 1.5, so just pick one. I'm going to go with the 3 over 2 because it's a fraction. I know it's the same for the x and y, so it's 3 over 2 x, comma, 3 over 2 y. That's your mapping rule. So we did, in fact, prove that these were parallel, everything was parallel, and it did go through the center of dilation. So we were able to find it through the origin. So since it went through the origin, we have a mapping rule. This last one, again, we're going to find a prediction. If we look at the original, the pre-image to the image, it looks as if it moved around quadrants, and it also is in a completely different orientation. So this looks like it might be a rotation. And then once we prove that it is a rotation and it has a center of rotation, we'll be able to figure out what degree it is. So the properties for rotation is that AR is congruent to A prime R, BR is congruent to B prime R, and CR is congruent to C prime R, where R is the origin, or the center of rotation. So it should be the origin. And if it is the origin, that means we have a mapping rule. Okay? So when we see that congruent symbol, I'm going to highlight that in green, but I actually have to highlight all of them, because these two values right here will be the same, but they will not be the same as these two values. These two will be the same, but they will not be the same as these two values. So I actually have to find all of them. Now, I have 1, 2, 3, 4 lines, so I'm actually going to have 4 of these. So got to make sure we do all 4 of them. So to prove congruent, we want to do our Pythagorean theorem. So if we're congruent, we're going to use Pythagorean theorem, a squared plus b squared equals c squared. C squared is, the c is your hypotenuse, which is the line we're trying to find. So if we remember, c is actually equal to the square root of a squared plus b squared. If we want to get c by itself, we'll take the square root of it. Okay? And again, we're just going to create right triangles, or count if we can. Our R, our center of rotation, should be at the origin. And if it is, that means that we've done everything right. So this, we're going to put R as our center of rotation, as our origin, so that we can do the rest of this. So we have the distance of AR equals, and we want to do A prime R equals. So we're going to do those. So we do our A, which is actually, it's not going to be A, we're going to pick, we have B, C, Z, and X. So I'll pick, let's go with B. So BR and B prime R. Let's go with that. So BR and B prime R. B to R is just 1, 2 away from it, because it's a horizontal line. You can easily just count. That's 1, 2 away. So the distance of BR is just 2. From B prime to R is also just 2. So these are congruent. So that's good. We needed to prove that. So we've proved the first one. We just have to do all of them. So we have 4 of them we have to do. So then we'll go to, let's go to C, B to C. So CR and C prime R. This time, because you have to go from C to R, you actually have a hypotenuse. So we're going to create a right triangle. So we have 1, 2, 3, 1, 2, 3, 4. So I actually have the square root of 3 squared plus 4 squared. 3 squared plus 4 squared, so that's 9 plus 16, it's 25. So we have the square root of 25. The square root of 25 is 5, so that's our distance from C to R. Now we'll do C prime R. Do the same thing from C prime to R. So right triangle, go down to the left. We have 1, 2, 3, 4. 1, 2, 3. So we have the square root of 4 squared plus 3 squared. 4 squared is 16, 3 squared is 9, so it's 16 plus 9. 16 plus 9 is 25, and the square root of 25 is 5. So these are also congruent. So that's good. The next one we'll do is we'll go from Z to R. So we'll talk about Z, R, and Z prime R. So Z to R. From Z to R, so we go down 1, 2, 3, 4, 1, 2, 3. So that's actually the same thing. So that's the square root. So we have 4 squared and 3 squared, which was equal to the same thing from over here. That's still just equal to 5. So then Z prime R. We'll go down 1, 2, 3, then 1, 2, 3, 4. So that is also 3 squared and 4 squared. So square root of 3 squared plus 4 squared, which again from here we know is actually just going to be 5. So those are also congruent. So we've proven 3 of them. We just have to prove the last one, and if we can prove all of them, then it should be then it will be a rotation. So for X prime, or XR and X prime R, XR and X prime R. So from X, we have to go from X to R. We go down 1, 2, 3, 4, and then 1. So we have 4 squared plus 1 squared. So 4 squared is 16, 1 squared is 1. So 16 plus 1 is 17. So we just have the square root of 17, which is a decimal, so I'm just going to keep it a square root of 17. So I don't have to write the decimal. Then we'll do X prime R. So we'll do the same thing, X prime to R. We have 1, then 1, 2, 3, 4. So again, we have that 1 squared plus 4 squared. So 1 plus 16 is 17. So again, we have that square root of 17. These numbers are the same, therefore these are also congruent. Now it does not matter, it really doesn't matter if these are congruent to these. And the fact that these here are also congruent does not matter to us. It just was a coincidence. So as long as these two are congruent to each other, these two are, and these two are, then you have a rotation. And it was at the origin, so that means that we do have one of the mapping rules. So we have one of those mapping rules. It's either 90, 180, 270, or 360. So if we look, this is a rotation. We can figure out the degree by going from your pre-image to your image. Got to figure out, if we just focus on any of the coordinates, so if we focus on C, how do we get to C prime? Again, it's counterclockwise, so we have to go around the quadrants. How many quadrants does it move from? So we would have to go from quadrant 2, so then we'd have to go to 3, 4, and then up to 1. So that's 1, 2, 3 quadrants they move. 3 quadrants means that's 270 degrees. So it's a rotation of 270 degrees counterclockwise. Which that rule, that mapping rule is XY maps to 270 degrees is y comma negative x, close parentheses. You can actually see that with your coordinates as well. If you actually had the coordinate of C and C prime, C is at -4, 3. So if we were to, so -4, 3, just going to show you, this is at C, so C prime, 270 degrees, would be at 3, -4, and then you have to negate the back number, so it should be at 3, 4. 1, 2, 3, 1, 2, 3, 4, which is correct. So that is actually correct. Our rotation of 270 degrees counterclockwise is correct, and we have proven it using the properties.